Hello, and welcome to today's daily Leetcode challenge. Today we'll be solving question 138, copy list with random pointers. I'll be going through my thought process as I come up and solve the problem. Finally, stick around for the end of the video where I compare my solution to the solution of other Leetcode solutions. With that, let's begin question 138, copy list with a random pointer. And all right, like I have already solved this probably a while ago. A linked list of length n is given such that each node contains an additional random pointer, which could point to any node in the list or null. Construct a deep copy of the list. A deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value corresponding to the original node. Both the next and the random pointers of the new nodes should point to the new node in the copied list such that the pointer in the original list and the copied list represent the same list state. Note, none of the pointers in the new list should point to the nodes in the original list. And then there's an example. However, let me just restate it with my own words. There's, as an input, I get a linked list. Everyone should know what that is. However, this linked list has an additional property. Each node in the linked list has an additional pointer in addition to next called random. And this random node pointer, it points to any node in the linked list. How that makes this problem more difficult is that originally, if I was to just implement a deep copy of a linked list, I would have traversed the input linked list, and as I'm traversing it with each new node.next, I would have the ability to create another node on the result of the deep copy essentially, and I would have no issues with linking those two nodes in the deep copy together. However, in this case, the next is still pointing to a node that is going to be next. However, random could potentially, theoretically, point at any node in the input array or in the input linked list, meaning that I have no way of creating the random pointer and then also making sure that that random node that it points to will then eventually get picked up by one of these later node.next pointers. And so, um, yeah, that's just a quick TLDR of what I think the challenge is going to be. As an example, if there are two nodes, capital X, capital Y in the original list, where X dot random points to Y, for the corresponding two nodes X, Y in the copied list, X dot random will also point to Y. Okay, all makes sense. Return the head of the copied linked list. The linked list is represented as an input-output as the linked list is represented in the input-output as a list of n nodes. Each node is represented as a pair of val random index, where val is the integer representing node.value, and random index is the index of the node from 0 to n minus 1. Okay, and then we have some examples. This is what it was talking about, how it's represented. This is the value, this is where random is pointing to value, where random is pointing to, and so on and so on. Okay, so with that, let's think about how to implement this. Well, the challenge, as I mentioned before, is that random is going to be pointing to a node that isn't necessarily the next node that I'm going to explore with node.next. And so I have to somehow identify I have to keep track and identify where in the input linked list is random pointing to. And since the node itself has no idea about if it's first, second, or third, or even last, I have no way of knowing where the random points to. So my idea is, what if on the input, linked list, I append an additional value. This additional value is going to be simply of the index representing the order of the node in the linked list. So imagine that in addition to next and random, it also has another value called index. That way, when I uh, when I populate this, sorry, no, not populate. That way, when I traverse it a second time, I will know exactly where random is pointing to. I will not know exactly the node where it's pointing to, but I will know to which index it's pointing to. So, for example, let's say that I now have, um, let's say that instead of just having head as my input, I now have node 1, node 0, node 1, node 2, node 3, node 4, and so on and so on. And when I'm trying to reconstruct it, I will see that node 0, well, I know that node 0.next is going to be pointing to node.1 just because it's in the next, it's the next node that's coming up. But if node.zero's dot random points to, let's say, nodes 3, and node 3 has an INDX value of 3, well, all of a sudden I know that this node that I have to, this copy node that I have to make of 0, it's going to be automatically linked to a node that will appear. See node 3. I will know that it's going to be a node that will appear in the 4th position. There we go. So again, the nodes here are, the nodes here now have a property that not only do they point to a next and a random, they also tell me which index, which order are they in the input linked list. Because when I try to replicate this node, I will know where it's pointing to next. I will know where it's pointing to randomly. And since I know where it's pointing to randomly, and I already have presumably a node made in my deep copy, I will just know that this goes directly to this index. Okay, with that, I think I have a pretty good understanding of how to do this. Now let's get to the implementation. So first, just traverse the input linked list and initialize it with a bunch of, well, okay, initialize it or add an additional value to it that's going to be called index. And what else? Oh, and then at the same time, I could memorize how many nodes are there even in head, so I can make this new, I could make this new output array, right, of output linked list. So let's call I 0. Let's say that the input linked list. Let me think of a more direct name for my head. Input. I don't actually need, I have input head, so I have put node. It's going to be equal to head, right? And then I say while input node, I'm going to, okay, I also need the output link list. It's just going to be this. And let's say that while input node, I'm going to say output node list append node with a value of input value. Input node value. And what else? Well, I have this I for a reason. I want to say that input node.indx is equal to I. What else? What else can I do here? That's it. That's all that I can do for now. I plus equals 1. And at the end of this step, I should have both of these structures essentially available to me. I have a pre-populated output node list with all of my output nodes that are eventually going to be turned into a linked list. And I know in my input node array what each of the indices, what each node's index is. Let's print it. Actually, I don't know if that's actually going to work. But let's try printing, and let's see. And I always forget to do this. Input node next. Input node equals input node dot next. Sweet. Great. I have my standard out, which is just a bunch of nodes. Great. Now that I have this, what do I need to do next? Well, I need to repeat this process of iterating over my input node, over my input nodes, but this time I don't need to create any new nodes. I just have to know where and how to link them. So let's say again that my input node is going to be equal to head, and let's say while input node, okay, what now? I need to know the next index. So, okay, hold on. To figure out where this is pointing to next is pretty trivial. The next is just going to be the current nodes plus the okay, instead of using this guy, let me say that I is equal to input node indx. I have I. I know at which index my node lies. Now I need next indx. So where my next pointer is pointing to. And how am I going to do that? That is going to be this next indx if input node next else -1. So my next index, but I don't need the next index, right? No, I do need the next index. No, yes, I do. Is going to be the input node of the next indx plus input node next. I could have just said I plus 1. Should I just do that? But then I have to do a weird condition where no, I'm just going to keep it, and then random index is also equal to the input node random index if input node random else -1. Now what am I doing here? I'm saying that next random index of the random node is just going to be input node's random index if input node random exists, else -1. Alrighty, now I need to assign these things. I need to assign them to my output node list. So output node list I, that's the current index that I'm looking at, put next to I is equal to, oh, no. Next is equal to output node next indx, and this is going to be random indx is pointing to random indx, except this is just called random and this is called random indx, and this is called next indx. Sweet. So what am I doing here? While input node is not none, I'm going to identify which index I'm currently looking at. I could be doing this with just a simple iterator, but this is a bit more clean because I know exactly. I'm doing this iteratively. I'm iterating over the input linked list rather than just iterating over the value I, which is a bit arbitrary. Indx, let's call this indx actually. Okay, and now I think I should input node next. Oh, and one more thing here. If this is bigger than 0, bigger or equal to 0, else none, and I'm going to do the same thing here. Random indx equals none, and then return output node list -0 first value. Let's see if this works. It's way cleaner than what I initially wrote. Sweet, submit. And index out of range because this guy probably has not been initialized at all. So let's see if not head, return none. Nice. And yeah, it seems like I've done this a really long time ago, about 2 years ago. Okay, let's see how we did. I hope this is very clean and wow. Okay, this is not fast. Not fast at all. Let's see how we did, I guess. What are some other approaches? Okay, wow, this is really way faster. So I was a little bit hesitant about modifying the input linked list, but maybe that's where we're paying the price. So I'm looking at the fastest 14 millisecond runtime rather than mine almost 45. 4 times faster, 3 times faster. So the idea here is that Yeah, okay, so this is the initial condition edge case. I make a root with a head and a none. Root with a node of value 0 and head and none. Claim that size is 0. And while head dot next is equal to node head dot val head dot next head dot random. Are they modifying in place? Are they? I'm pretty sure that they're modifying the input array as well. Head dot next is equal to, all of a sudden, a new node where head dot value what are they doing? Are they overwriting what is in the existing head? They made a root node which precedes the head node. And so just to visualize that, that's a node right before head. Then say that size is 0, and then while head being the input to the linked list, they're saying head.next, which means that they're overriding what's in head is equal to node head.value, head.next is equal to a new node, head.next is equal to a new node with the value of head, next value of head.next, and a head.random. Wow, I am super confused. Is there another, maybe, solution that's a bit simpler? Okay, let's see. At least, I mean, here at least they're using a dictionary, so maybe that's a more similar approach to what I did. While dictionary, sorry, no, not while dictionary. They just made a dictionary, and then the new pointer and the previous pointer. New pointer and previous pointer. While head node is equal to node head.value, next pointing to none, and head.random. Okay, so this new node has the value of head, doesn't point to next, and has the random pointing to heads.random value. If new pointer is none, then new pointer is equal to node. So they have this new node that is almost identical to head with the exception of the next value. And then they're saying if new pointer is none, meaning that it hasn't been initialized yet, then new pointer is equal to that node, and previous pointer is equal to that node. So if this node, if new pointer is none, then essentially add new pointer and prev pointer to node. Okay. And then dictionary of head. How did they hash? Is that even possible? Can they even hash? And then head dictionary is equal to node, and then head is equal to next. Wow, I am very much stuck. I mean, I'm tempted to just read the solution, but I mean, yeah. Is there an explanation? Strategy. First create all the new nodes, then assign next and random pointers. That's what I did. M. Map none to none for nodes that have no next or random pointers. Current equals head, while current node. Copy, current equals node. So here they're making this map. Okay, this might be easy to understand. They are making this map of the current's hash to the copied node. Okay, they're making this hash where the current equals current.next, and then current equals head again, and for this I understand. This is almost identical to what we did. There are the two while loops. We're iterating over the input twice. However, I was not aware that we're able to hash the head such that, I mean, I don't know that it was a hashable value. So this actually makes a lot of sense. Let me repeat what's happening here. They're making a dictionary of the node's hash to the input node's hash to the new value, and so that way, when I'm iterating it the first time, I just make this map. But then when I'm iterating over it the second time, I can assign the copy next and random value to what is in my current next and random, and then current. Okay, let's implement this very, very quickly. I like this solution because it's so clean. Let's discard this. Let's have the copy map, which is just going to be a dictionary, and then node equals head, while node, I'm going to say that copy map node is equal to node val. That's it. Then I'm going to say, what else am I going to say? Node is equal to node.next, right? That's what they had. So at the end of this iteration, I have my copy map dictionary, copy dict, let's just call it by what it is, copy dict, node values, and then I do the same thing. Node equals head, and while node, I'm going to say current, I'm going to say copy is equal to copy dict node, copy next is equal next is equal to copy dict node next, and here the same thing but random, and then node is equal to node next, and then return copy dict head. This cleaner, way cleaner than what I did, and it's not modifying the existing the existing input array, except what did I mess up? Copy random node dot value, node equals node dot next. Oh, is this a fault? I mean, I remember how he did it there. Oh, default. That's why he had this, because this is the default. This is the default. None, none. He's mapping none to being none. I wonder if default dict none. Can I do that? No, I guess I really have to map none to none right off the bat. And then that works. This is so clean. Okay. I might be a little bit. Oh, but it's not much faster. Okay, well that just leads me to believe that it's fluctuating pretty hard, because this was almost one-to-one with what they had here, and this is beating pretty much everyone. Okay, I would say use this solution. I really like this. I really like how clean it is. I like how it was very easy to come to this immediately. Just didn't know that node was hashable, but I guess it is. It's not modifying the existing input linked list, and it's only iterating twice. That may be not the best case, but in terms of intuitiveness, please understand that that's a big factor, especially when doing interviews. With that, thank you. Thanks for watching. I'll catch you next time. Please like and subscribe, and stay updated with daily videos. Bye.